Chapter 2, Number 55. The speed of a bullet as it travels down the barrel of a rifle toward the opening is given by velocity equals negative 5.00 times 10 to the 7th times time squared plus 3.00 times 10 to the 5th times time, where v is in meters per second and t is in seconds. The acceleration of the bullet just as it leaves the barrel is 0. Determine the acceleration and position of the bullet as a function of time when the bullet is in the barrel. B. Determine the amount of time the bullet is accelerated. C. Find the speed at which the bullet leaves the barrel. D. What is the length of the barrel? First, we are given that the velocity of the bullet is equal to negative 5.00 times 10 to the 7th times time squared, plus 3.00 times 10 to the 5th times time. We are also given that the velocity is in meters per second, the time is in seconds, and the acceleration, which is labeled with an A, is equal to 0 meters per second squared. Then we are asked to find, for A, the acceleration and position of the bullet when it is in the barrel, B, time bullet is accelerated, C, speed bullet leaves barrel, and D, the length of the barrel. We start with part A with the equation acceleration equals dv over dt, which is just the derivative of velocity equals acceleration. When you plug in the necessary components for this equation, it should look like this. Once you take the derivative of velocity, you should get acceleration equals negative 10.0 times 10 to the 7th meters per second cubed times time, plus 3.00 times 10 to the 5th meters per second squared. To find the position equation, we should use the position initially is 0, the time initially is 0, and velocity equals dx over dt. Because of the equation velocity equals dx over dt, you will then get this. X minus 0 equals the integral from 0 to t of velocity times dt. Once you take the integral from 0 to t of velocity times dt, it should look like this. Once you solve for x, you should get x equals negative 5.00 times 10 to the 7th times time cubed divided by 3, plus 3.00 times 10 to the 5th times time squared divided by 2. When you simplify your equation further, it should look just like this. For B, we are given that the bullet escapes when acceleration equals 0. When acceleration equals 0 and you plug it into the acceleration equation, it should look just like this on the right. When you solve for time, you should get time equals 3.00 times 10 to the 5th seconds divided by 10.0 times 10 to the 7th. This should then equal 3.00 times 10 to the negative 3 seconds. The new velocity when you use the time that you just found in part B would be this. You plug it into the velocity equation and it will look just like this. When you simplify the equation, you should get velocity equals negative 450 meters per second plus 900 meters per second, which will then equal 450 meters per second. To find the position when acceleration equals 0, you use the time that we got in part B. You then plug this into the position equation. It should then look like this. When you simplify this equation out even further, you will get position equals negative 0.450 meters plus 1.35 meters, which will eventually equal 0.900 meters.